so here we go. Area is equal to the limit as n goes to infinity of the sum. Remember, this little sigma guy means sum of the areas of each of my rectangles. So we have our height times our base, or our length times our width. So it's really important that the I is understood as some ith rectangle in the middle of my picture, in the middle of my sequence, okay? So I start with going from the left boundary, in this case is 0, to the right boundary of 2, because I'm going from x is equal to 0 to x is equal to 2. And when I write out this and I look at dividing this into some nth strips that are of equal width, okay, I don't know how many rectangles that is. It's n rectangles. So I have the first rectangle, the second rectangle, the third rectangle, then a whole bunch of rectangles. Then I have the ith rectangle somewhere in the middle. She called it the K rectangle in hers. Then there's a bunch of more rectangles, and then we get to the nth rectangle. Okay, so understand the difference between the ith rectangle and the nth rectangle. Okay, the nth rectangle gets you all the way to the very end of the sequence. The ith rectangle is somewhere in the middle. Okay, so once we've divided our diagram, so this is y equals x squared, we're looking at this approximation underneath of the y equals x squared, the area. We need the width. Okay, so the width is the change in x is the left boundary minus the right boundary over n. So in my case, b is 2, a is 0 over n. So the width of our rectangles is 2 on n. And the height of my rectangles, okay, so all of these, let's make that a little thicker. All of these heights that I have to come up with a formula for, we need that to be represented as f of a plus the ith width. Okay, so ith rectangle. So it's trying to get to where are we on our x-axis. That's basically what this is trying to get to. Okay, so in the first rectangle, that's 2 on n. In the second rectangle, that's 4 on n. Okay, for the ith rectangle, it's 2i on n. So if you think about this, the second rectangle, so 2 on n times 2 is 4 on n. And then the third rectangle came out to be 6 on n. So 2 on n is the width times I need the third boundary for this height would be 6 on n. Okay, so if I get to this one in the middle, how do I represent him? Well, I represents the third rectangle, the fourth rectangle, the fifth rectangle, somewhere in the middle. Okay, so back to this formula. A is 0 plus the ith rectangles times its width is 2i on n. Okay, lots of people forget about this little a guy. Okay, so if we don't start at 0, if we start somewhere like further along on the x-axis, it's really important to get that correct, so we are getting the correct height. Okay, so here is our heights. Our heights will be f of 2i on n. All right, so we have a representation for our width and a representation for our height. Now we're going to use sigma notation, which she didn't use, although she ends up using a formula from it. Pardon me. We are going to use sigma notation to represent the sum of our areas. So we're going from I is equal to 1 to n. Now we're going to multiply our width times our length, which is f of 2i on n. I didn't really need that extra set of brackets. That's okay. Okay, so it's the change in x times our length, our height. All right? Okay, so let's now work with this. Okay, you might have to write small. Let's see. So you can't drop your sigma notation until you can get to a spot where we can use one of those funky formulas from the front. Okay, it's kind of like the limit guy. So we're adding up the sum of 2 on n times f of 2I on n. Now remember, what was our function? Our function was y is equal to x squared, or f of x is equal to x squared. So this guy right here needs to go in for my x, okay? So now I have, this is 2I on n squared. And then we will try to tidy this up. Okay, so this is equal to the sum I equals 1 to n of 2 on n times, what's 2I on n squared? So that would be 4I squared on n squared. And that then becomes the sum of 8I squared on n cubed. Okay, now I can take out the 8 on n cubed in front, and then I'm left with adding up all the I squareds. That's your 1 squared plus 2 squared plus 3 squared plus all the way to I squared. This is our formula that we're looking for. Okay, this is the guy we're trying to get down to one of those I formulas from the front. Okay, and then that little piece here is equal to n times n plus 1 times 2n plus 1 all on 6. So I can replace my sigma notation with that little piece. So now I have that this is equal to 8 on n cubed multiplied by that formula, n times n plus 1 times 2n plus 1, all on 6. Okay, now I am allowed to drop my sigma notation, and I'm going to try and tidy this up. Okay, so I have that this n can become an n squared because I can cancel that n on the top. Okay, and then the 8 on 6 can become 4/3. So 4 on 3n squared. And then I'm going to FOIL out that top. So that would be 2n squared plus 3n plus 1. And really, it's all over top of that. And let's see. Let's then leave it like that. Let's do the limit now. I don't know if I wrote that in here that I was going to take the limit next. Yeah, so step 4, I think, is we're going to take the limit. Okay, so now I can say that the area is equal to the limit as n goes to infinity of this function I just made. So 4 times 2n squared plus 3n plus 1 all on 3n squared. And using my properties of limits, I can actually take that 4/3 out. Okay, you can multiply it in or you can put it in the front. So 4/3, the limit as n goes to infinity of 2n squared plus 3n plus 1 all on n squared. And hopefully we are now thinking I have to divide everything by n squared. She didn't really do that. Tisk, tisk. She didn't show you guys. She just verbally walked you through it. I'd like to see you do this step, please. To show your understanding of how these limits get equated. So on your show you know, please be very thorough and show me this step. Okay, and then anything, of course, pardon me, that has a smaller exponent on the top is going to go to 0. And then that leaves me with this limit piece right here is going to equal to 2. And then I still have to multiply that by the 4/3. Okay, so then this n squareds cancel, leaves me with 2 on 1. And then I can say, therefore, the area is equal to 4/3 times 2. So as an exact value, that's 8/3 units squared. Woohoo! We made it through the first crazy example. Well done. Okay. So here is an example that starts with a boundary of 1 instead of 0. So how does that affect how we equate the answer to this? So I would encourage you to, before you press go on the next video, to figure out what is your width, what is your height functions value, thinking about the formula, thinking very carefully about how x equals to 1 as my left boundary is going to be different than 0, and see how far you can get. Okay? And I'll see you back in the next video.